Hi everyone, welcome back. Today we're going to talk about measuring the pH and the pH of strong acid and strong bases. It's chapter 16.2B+C. Okay, what we're going to do. So first let's repeat a little bit. Assessing the pH. Minus log concentration of H plus or concentration H3O plus. Remind again, H plus is the same as H3O plus, since H plus H2O makes H3O plus, so they're exactly the same. So if you know the concentration of H plus over H3O plus, you can assess the pH. If you know the pH, you can assess the concentration by 10 to the minus pH. When you know the concentration of OH minus, you can assess pOH. My pOH is minus log concentration OH minus. If you know the pOH, you can assess the concentration OH minus by 10 to the power of minus pOH. And remember, with the water constant, always pH plus pOH is 14. And the water constant is the concentration of H3O plus times concentration of OH minus. So when the pH is 7.00, the concentration of H3O plus and OH minus are exactly the same, 1.0 times 10 to the negative 7. There are several ways to get an indication of the pH, so measuring the pH. Indicators, indicator paper, pH meter. So indicators that are substances, most of the time liquids, you can add to solutions, and depending on the pH, they will have a different color. A very common used indicator is phenolphthalein that makes solutions have a red-purple color when the pH is above 10, and colorless when the pH is smaller than 8.2. And between 8.2 and 10, they change color, so there will be a little bit of pink. Just when we finish this presentation, have a look at this movie, you can see the different colors. In your book at page 7012, there's an entire list of various indicators, and you see when you add an indicator to a solution, depending on the pH, what color you will have. So another indicator, if we have an acid or a base, is litmus paper. We have blue litmus paper that turns red, indicate we have an acid, or we have a red litmus paper we can use to find out if we have basic solution. A drop of basic solution on the red litmus paper will turn blue. So that's more qualitative, acid or basic. So then we have also indicator paper. Have a drop on the indicator paper, you see the color compared to this wheel. You can find out if the pH low is from 1 to 3 or high is more like dark blue, almost black. Then universal indicator paper is turning blue, black when high pH. Next, we also have a pH meter. So we have a pH meter, we put it in a solution and we can read the pH. That's the most easiest way to do. We have to calibrate it, but we can use that. Finally, I want to talk about strong acids. So the difference between strong and weak acids or bases. With strong acids, strong bases, we have complete dissociation into the ions. So for example, HCl, that's a strong acid. I have the maximum amount of H3O plus. And the Cl minus, but that's okay. We're now interested in H3O plus. So when I have 1 moles per liter of HCl, I also have 1 mole per liter H3O plus. 0.05 moles per liter HCl, I have 0.05 moles H3O plus because HCl is completely dissociated in H3O plus and Cl minus. So when I know the concentration of my acid, my strong acid, I also know the concentration of my H3O plus. So for here, 1m HCl, 1m H3O plus, and I can plug that information into the pH. So if I know the concentration of my acid, strong acid, I know the pH. Here example, when I have 1m HCl, the pH is minus log the concentration, minus log 1.0 makes, I think, 0. So strong acids, we only know, I think, 7 strong acids, and here they are. Nitric acid, hydrochloric acid, hydroiodic acid, hydrobromic acid, sulfuric acid, and now we have to take into consideration we have a 2 over here, H2SO4. So 1 unit of H2SO4 can split off 2H+. So 1M H2SO4 gives me 2M H3O+. And when we have weak acids, we do not have a complete ionization. So 1M Ca3COOH will not give me 1M H3O+. You can see it over here because it's a weak acid. So here we have strong acid. When I know the concentration for H3O+. The same is for strong bases, but then we have the pOH or the pH. With pH plus pOH is 14, I can assess the pH as well. So here are a couple examples. NaOH, sodium hydroxide, is a strong base. 1M sodium hydroxide gives me 1M OH-. Potassium hydroxide, the same. Completely dissolves the maximum amount of OH-. So 1M KOH gives me 1M OH-. For this one, 1M sodium oxide gives me 2M OH- because O2-, that's the base. It accepts an H+ from water, forming OH-, but water is releasing one, so also an OH-, so 2H-. So 1 mole of Na2O gives me 2 moles of OH-. Because we have a complete dissociation. But for Na3, that's not a strong base. I will not have 1M OH- when we have 1M Na3, because Na3 is a weak base. Okay guys, for next class I want you to study chapter 16.2B+C. That's about measuring pH and a little bit about strong acids, strong bases, assessing the pH of these. Okay, that's it for today guys. Bye-bye.